Well, now we've got a linear programming problem. We're going to have a few variables. How many of each vehicle, so I go right to the question to see what type of variables we need to be using to minimize the cost. Well, the cost comes from renting buses and vans, so I'll use B for bus and V for vans. And then on those, here are the requirements for how many students and how many chaperones. So S for students and C for chaperones. As far as the students, it says that they want there to be at least 400 students and no more than, or in other words, less than or equal to 36 chaperones. And now a bus can carry 40 students while a van can carry 8 students. So counting up the students, we would have 40 students per bus plus 8 students per van, and we want at least 400 to go. And then as far as the chaperones, it's 3 and 1. So we'd have 3 on a bus plus 1 in a van, and that has to be less than or equal to 36. And of course the number of buses and vans needs to be bigger than or equal to 0. And now as far as the money, so minimize the cost. So the cost, I will use M for money, is going to be $1,200 for a bus plus $100 for each van. So next we need to find out what's this region, and then find the corners of the region, and we'll find out the minimum for the money. So I'm going to make a table of values for each of these. So with 40B plus 8V equal to 400 students, we'd have, if it was only vans that went, then it's going to require 50 vans. And if only buses went, it would be 10 of them. And now plot that information. So this is going to be the B-axis, and this is going to be the V-axis. And we've got 50 for vans, and we've got 10 for buses. That's part of the region. And now for this other line, so 3B plus V equals 36. Make a little table of values with B and V. And if the buses was 0, then it would take 36 vans. And if the vans were 0, it's going to be 12 for the buses. So 12 for the buses, and then 36 for the vans. And then make that one a blue line. And then the region is going to be, well, it has to be between 0, and in fact it's going to be between 0 and 10 in here, and 0 to 36, so it's going to be this region in here. And consequently we need to know where do those two intersect. So in this equation, maybe I should use this one, solve for V. So V is equal to 36 minus 3B, and then substitute that information into this equation. So 40B plus 8 times the 36 minus 3B equals 400. And now distribute the 8 times 36 is 288, and then minus 24B, the 400 still there, and the 40B at the beginning is still there. And then it's going to be 16B equals of 400 minus 288 is 112, and then divide that by 16. So the B is equal to 7. So 7 would be right about there. That sounds right. So 7 and what? And then substitute that back into this one, and we'll have that V is equal to 36 minus 21. So 15. And a 15 is less than 36, so that makes sense. Alright, now we have all of the points. I suppose I will still need this. So now we've got for B and V and M, make a table of values. And then the points are the origin, so 0, 0. Although in this case that wouldn't make much sense to have 0 buses and 0 vans, because then 0 people would go. So we need positive values. We've got this corner, which is 10 and 0. We've got this one, 7 and 15. And this corner, which is 0 and 36. And then substitute those into this function that we found a while ago. So this one is going to be 1200 times 10 plus nothing else is $12,000. And then use a 7 and a 15. So 1200 times 7 plus 100 times 15 looks like a better deal, 9,900. And then if it was all vans, it's going to be 100 times 36 would be 3,600, even a better deal. And so there is the minimum cost, $3,600.